Moving right along, we're up to 9-4 ellipses. Now, I know I'm kind of beating a dead horse here, but you got to watch the pre-lessons for all of this to make sense. Now, ellipses are a lot easier than parabolas if you get the gist. So with that being said, again, if you haven't watched the pre-lesson, just stop this video right now and watch it, or else a lot of what I'm about to do won't make sense. So, this says, graph each ellipse and find its foci. Well, we know that when we're dealing with ellipses, that a squared is always bigger than b squared. So this is a squared. A squared equals 16, so a is 4. B squared equals 9, so b is 3. This is how far I travel along the x-axis. Remember, this is my x-axis, this is my y-axis. 1, 2, 3, 4, put a dot. 1, 2, 3, 4, put a dot. And then I travel along the y-axis. Notice this is underneath y, and that's where I get the information. That's what's telling me to go up the y-axis 3, down 3. It's going to look like a circle, maybe, but it's not, because my x-axis is a little bit longer than my y-axis. Now here comes the tricky part. Foci. We're going to get the foci from this little formula right here. So c squared equals a squared, which is 16, that's what that is, minus b squared, which is 9. So I get c squared equals 7. Now here comes the key. Take the square root of both sides, bada boom, bada bing, do the right thing. This is going to come in handy now. I have to determine which axis the foci are on. Remember, the foci are always on the major axis, which means the longer one, which in this case, this is 4, this is 3, so my x-axis is my major axis, which means I need to go this way, the square root of 7, and I need to go that way, the square root of 7. Which tells me I'm going to take this information, I'm going to go plus or minus the square root of 7, comma 0. If I screw these up and I go 0 plus or minus the square root of 7, these dots would end up on my y-axis, and that's not my major axis. That's why this is the correct answer. Let's go on to the next one. Very similar. Notice the difference, though. This one was already set up. It equals 1. Remember that in the pre-lesson? This one does not. So the first thing we have to do is divide everything by 64 and then reduce it. So I get x squared over 64 plus, now 16 over 64 is really 1/4. So I'm going to write it as y squared over 4 equals 1. Very obvious that this is bigger than this. So my a squared is 64, which means my a is 8. So I just take the square root there. And then b squared is 4. So I take the square root and I get b is 2. So I travel along the x-axis 8 units. I know this is 10, so I'm going to come in 2. Then I'm going to go up 2, down 2. Now this is going to look a lot more like an ellipse than the previous problem. The previous problem looked like a circle. And it's pretty obvious that my x-axis is my major axis, which is huge for this next step. So I'm going to use this formula. C squared equals a squared, 64, minus b squared, which is 4. So I get c squared equals 60. I go bada boom, bada bing, do the right thing. And I'm not really sure if Algebra 2 in this particular instance is going to make you break things down. I'm not sure. But let's go ahead and do it, because that's 4 squared of 15, so it'll be plus or minus 2 square root of 15. So I have to decide, is it going to be plus or minus 2 square root of 15 comma 0, or is it going to be 0 plus or minus 2 square root of 15? And I can answer that by saying, well, which one of these ends up on the x-axis? And it's this one. Why is that important? Like I said, your foci are on your major axis. It just is. You can look up here at this drawing. See the F and the F? It's on the major axis. So if you tilted this thing like this, now your major axis would be your y-axis if you thought of this as your x and y. But anyways, Yeah, like this one over here. I didn't see that one. Okay, so now, just giving us some bigger headaches to deal with, but remember, it has to equal 1. So that's what drives the machine here. So we're going to divide by 9. So we get x squared over 3. This gets a little weird because of that darn 3. Plus y squared over 9 equals 1. Now this time, I can tell that this is bigger than this, so my y is going to be my major axis. But this is my a squared. A squared is 9. B squared is 3. Take the square root there, so a is 3. I got to travel up the y-axis 3, down the y-axis 3. And now here comes a weird moment. We get the square root of a non-perfect square root. Well, you got to get your calculator out to figure out what that is. I've done it so many times that I know it's approximately 1.7. So I'm going to go 1.7 in this way, 1.7 in this way. Draw this cute little rascal. There he is. But we still got to find the foci. Remember the formula. C squared equals a squared minus b squared. So c squared equals the bigger number in my denominator, which is 9, minus the smaller number in my denominator, which is 3. So I get c squared is 6. Take the square root, bada boom, bada bing, do the right thing. And I get plus or minus the square root of 6. Remember, my y-axis is my major axis. It's longer. So I got to make sure however I write this point needs to end up on my y-axis, and that would only happen if I put the 0 in the front and plus or minus square root of 6 in the back. All right, last one. Got to divide everything by 48 because this has to equal 1. Reduce this, x squared over 12. 3 over 48 turns into 1/16. And the closer these two numbers are to each other, the more like a circle it's going to look like, okay? So this is my a squared. So a squared equals 16, so I can see a equals 4. B squared equals 12, which if you take the square root of both sides, which I didn't show my work over here, but then a lot of you are going to go, aha, I got to break that down to the square root of 4, square root of 3, which is 2 square root of 3. You're not wrong, but this is graphing. So if I take my calculator and figure this out, square root of 12, I don't really need to break it down. But I just said the square root of 3 is about 1.7. So 2 times 1.7 is approximately 3.4, which approximations are fine in this. So we're going to go 3.4 along the x. 1, 2, 3.5-ish. 1, 2, 3.5-ish. Then I got to go 4. 1, 2, 3, 4 up the y. 1, 2, 3, 4 down the y. Connect. Looks like a circle. Not really. This looks like an ellipse. Our y-axis is definitely longer because 4 is bigger than 3.4. That means whatever point we choose for the foci has to be 0 plus or minus something. It just has to be because this is the only way it's going to end up on the y-axis. So here we go. We're going to use our formula. C squared equals a squared minus b squared, which is nice because c squared equals 4. Take the square root. We actually get a nice, neat number. So it's going to be plus or minus 2. And there's my foci. So I think you guys can tell ellipses are a lot easier than parabolas. So enjoy your homework. Shouldn't take you long.